Today we're going to add on to our trig problems by looking at angle of elevation and angle of depression problems. And at the very, very top of our paper it says angles of elevation, and then there's a little note that many real-world problems that involve looking up to an object can be described in terms of an angle of elevation, which is the angle between the observer's line of sight and the horizontal line. So I kind of think of it this way. If I'm standing somewhere and I'm looking straight ahead, that's my line of sight. If I then turn my head to look up at like the top of a tree or the top of a building, that angle that's formed when I turn my head from looking straight to look up at something, that angle is the angle of elevation. So it's basically the angle formed when I turn my head to look up. All right, so the first example that we're going to look at, this one says the angle of elevation from point A to the top of a hill is 49 degrees. So this angle right here is 49 degrees. If point A is 400 feet from the base of the hill, so point A is 400 feet from the base of the hill, how high is the hill? So we're looking for the height of the hill, so we'll call that x. We have two sides and an angle, so we're going to use trig, and now it's just a matter of deciding what formula we're going to use. So I mark my hypotenuse, find the opposite and the adjacent, circle the two sides that are labeled, and it looks like I'm going to use tangent. So I'm going to plug into my formula, which is tangent of theta equals opposite over adjacent, and then plug in what I know. So tangent of 49 equals the opposite side over the adjacent side, and then it's just a matter of using your calculator to solve for x. The second one says find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. So this time we're looking for the angle of elevation. We're going to call that x. We know that the telephone pole is 12.5 meters tall, and it casts a shadow that's 18 meters long. So again, with this one, I have two sides at an angle, so I'm going to use trig. So I label my hypotenuse, my opposite, and adjacent. And again, for this one, it looks like I'm going to use tangent. So tangent of theta is equal to the opposite over the adjacent, and then we'll just plug in tangent of x equals the opposite over the adjacent. And again, calculator at this point, just a little note that on this one we're looking for an angle, so you're going to have to use tangent inverse. All right, and then you can go ahead and try the two problems at the bottom. For those, there are no diagrams, so you do have to draw your own picture. But go ahead and try them and see what you come up with for those two. All right, on the back, we're going to take a look at angles of depression. And basically, angle of depression is the exact opposite. This is when you're standing, looking straight ahead, and you turn your head to look down. So your angle of depression is the angle formed when you turn your head to look down. Now, the other thing that I just want to point out is that your line of sight is always going to be parallel with the ground, and when you turn your head to look up or you turn your head to look down, you can kind of think of that as your transversal. So your angle of depression is also going to be the same as the angle of elevation because those are alternate interior angles. All right, so with that in mind, the first problem says the angle of depression from the top of a sheer cliff to point A on the ground is 35 degrees. If point A is 280 feet from the base of the cliff, how tall is the cliff? Well, we could think of this in two ways. I have my angle of depression up here, and so what I want to do is transfer that into my right triangle. So if it's 35 degrees up here, it's also going to be 35 degrees down there because, again, those are alternate interior angles. And now I'm looking at my right triangle. I have two sides and an angle, so I'm going to use trig. So for this one, again, if I label the sides, there's my hypotenuse, there's my opposite and adjacent, and again for this one it looks like we're going to use tangent. And then we plug in what we know, so tangent of 35 equals the opposite over the adjacent, and then we can go ahead and solve for x. The other way to think through it is to transfer this height over here and have your right triangle be over there. And then if this height is x, this height is also x. And if this side is 280 feet, this side is 280 feet. And now you could use that right triangle at the top. Same exact approach, but it's just what you want to move. Do you want to move the angle or do you want to move the sides? All right, for the second one, it says the angle of depression from a ball from a balloon on a 75-foot string to a person on the ground is 36 degrees. How high is the balloon? So here's our angle of depression, which I can move inside the triangle. And now I'm looking for the height of the balloon, and I know how far away the balloon is from the ground here on this hypotenuse. So I label my sides. There's the hypotenuse, there's the opposite, there's the adjacent, and so this time it looks like we're going to use sine. So sine of theta is equal to the opposite over the hypotenuse, and then again we plug in, so sine of 36 is equal to the opposite over the hypotenuse, and again we can cross multiply or multiply both sides by 75 and use our calculator to solve for x. And then same thing with number 3, go ahead and try that one and see what you come up with for answers. So basically every single problem on this paper should be done. I walked you through the setup for them, but you do need to go back through and type answers or get answers by using your calculator.